Today we're going to explore the different types of quadratics that we're going to graph this chapter. So yesterday we talked about standard form. Today we're going to look at vertex form and intercept form. So first off we've got vertex form. Okay. You notice vertex form looks a little bit different. However, we still got the square involved in there that'll give us the x squared. There's just a few different variables in there. Okay. So this one doesn't have an A, B, C. This one has an A, H, and K. So the A value is still the one that's just out front. Okay, that's going to tell us whether this thing opens up or down. Okay, the reason this is called vertex form is because this tells us what the vertex is just by looking at it. We don't have to do the whole negative B over 2A thing to figure that out. So with this first one, let's go ahead and identify our A value, which is 2. Okay, because A is 2, that tells us it's going to open up, which means it's going to have a minimum value. Now, next thing we're going to look at is our vertex. So the h is always in parentheses with the x. Now, the h is the opposite of what we think it should be. Just like with the absolute value problems, the h is the opposite of what we think. So if this looks like a negative 1 here, our h is actually going to be a positive 1. Our k is going to be negative 3. Now, what's great about vertex form is we already know the vertex. The vertex is at 1, negative 3. Okay, so we can center our graph at 1, negative 3. And that's just by looking at the equation and knowing that. Now, just like before, we're going to get the rest of these points from our calculator. So that should be 2, 3, 0, negative 1. So go ahead and plug those in, and points you should get are 5, negative 1, negative 3, negative 1, and 5. So we get that nice mirroring pattern on here. So go ahead and plot those points. And then draw your parabola. Okay, axis of symmetry, remember, goes right through that vertex. Okay, and we can also pull out the axis of symmetry right from the equation, because now that we know what the h value is, the x part of the vertex, we know that the axis of symmetry is going to be at x equals 1, that h value. So let's take a look at this next one. So again, A is always in front of that parentheses, so A is going to be implied to be negative 1, which means it opens down, which means it's got a max. Okay, H is the opposite of that parentheses, so it's going to be negative 5. K is going to be 2. So we've got a vertex at negative 5, 2. So let's go ahead and center our table at negative 5, 2. Okay, we're going to go to our calculator, we're going to get some more values. Okay, the values you should get here are negative 2, 1, 2, 1, negative 2. So when you're ready, go ahead and plot them. And then draw your parabola. Okay, so axis of symmetry, right down the center. Okay, and that axis of symmetry is going to be at x equals the x component of our vertex. Now, the second form we're going to look at today is what's called intercept form. So intercept form, we notice, has an A, a P, and a Q. So just like the last two, A is still going to determine whether this thing goes up or down. Okay, but what this one shows us is where it crosses the x-axis, the P and Q. So our A value in this first example is 2, okay, which tells us it opens up with a min. Now, P and Q, because they're in parentheses just like H, are going to be the opposite of what we think. So even though it looks like x minus 3, our P value is actually going to be positive 3. Our Q is going to be negative 1. Because if we were to solve this thing out, equaling it to 0, Okay, that's why it ends up flipping the sign in there. Now, this one's not as convenient probably as the vertex form because we do have to do a little bit of work to find the vertex, because what we've got right now is we've got two of these x-intercepts. So if we wanted, we could go down to our table, and we know that at 3, it's going to be on the x-axis. And we also know at -1, it's going to be on the x-axis. So we could go ahead and draw those on our graph. So here's an intercept. And here's an intercept. So, because those are two intercepts, and we know this is a parabola, halfway through those it's got to cross the x-axis. So sometimes you might be able to just look at it and tell where that happens. So if I look here between 3 and -1, kind of exactly right in the middle of those is going to be 1. Okay, so I know that this should have an x-coordinate of 1. If you were unsure of it, if you're looking at the graph and you couldn't count it out exactly, one of the things you can do is to find the halfway point of anything, we just add them up and divide by 2. So if I do 3 plus -1 and divide it by 2, it's still going to be 2 over 2, which is still going to be 1. So whether you use the little p plus q over 2 formula or you just visually find it on the graph, either one's really fine with me. Now, we know that the vertex is going to be at 1. We just happen to need some more points for it. So again, what we can do is, let's just go ahead and get these points from the graph, or from the calculator. So this should be at -8. Okay, and with vertex form, with intercept form, I'm actually okay with you guys just doing 3 points. Okay, you can do the 2 intercepts and then find the vertex, because really the whole reason that you do intercept form is you care about the intercepts. So let's just go ahead and go with what we've got right now. So at 1, -8 is going to be my vertex. And again, this is one of those ones where I'm actually okay with you guys only doing 3 points instead of our usual 5. So this is only with intercept form that you guys can do that. So let's go ahead and take a look at another one of these intercept form quadratics. So in this one, again, I've got an a value at -1, so the number in front of all the parentheses, which means it opens down, and it's going to have a minimum value. Okay, p's and q's are in the parentheses, so opposites, so p is -2, q is 3. So if we like, we can go ahead and jump down to our table here, and we know that there's going to be at -2 and 3, there's going to be x-intercepts. So this should cross the x-axis at -2, and it should also cross the x-axis at 3. Okay, we should be able to figure out what's exactly halfway between them. It may not always be so obvious. Like with this one, it's not going to be actually very exact. It's going to be at -1/2, or +1/2. Okay, so this might be actually a good candidate for us to have used our little p plus q formula. So -2 plus 3 over 2 gives me 1/2. Okay, so x equals -1/2 or 0.5. So that's where this thing should be sent at. Again, we just kind of need one more value, so you can go to the calculator if you want, but this one actually may not show up in the calculator because it's a decimal, so this also might be a good candidate to just plug it back into our original equation. So we had negative parentheses and then x plus 2, so we'll say 0.5 plus 2, and then x minus 3, so we'll say 0.5 minus 3. Simplify that, we should get 6.25. So that'll be the rest of our vertex. So at 0.5 comma 6.25. So do your best job, just estimate that point. And again, because this is intercept form, I'm okay with you guys not doing as many points. Now, on the bottom here, it says write the quadratic function in standard form. Okay, standard form, remember, is y equals ax squared plus bx plus c. So if you remember earlier in the chapter, I told you guys you can write any quadratic in any type of form and then graph it. Okay, so that's what we're going to do here. Is we're going to take one that's in vertex form and one that's in intercept form. We're going to try and break it back down to get it the way it was in the beginning. So let's take a look at the first one. So we've got y equals -2 times x minus 4 squared plus 35. Okay, so if we want to kind of break this back down to the way it was, I think the first thing maybe we ought to look at is that second power. Okay, x minus 4 to the second power is going to look like that. Okay, that all needs to be multiplied out. Now, one way I'm going to show you guys how to multiply binomials is using a box. So if we look at these two terms right here, okay, we need to multiply x minus 4 times x minus 4. Okay, I don't really do the whole FOIL thing. I don't do that stuff. The way I'm going to show you guys is we're going to use boxes. Okay, so we've got two terms times two terms. So we're going to do x minus 4 times x minus 4. Okay, every single box is kind of filled in by who's around it. So like if I want to fill in this first box, it's going to be x times x, which is x squared. Okay, x times -4 is -4x. X times -4 is -4x. And then -4 times -4 is +16. Okay, so what that tells me is the product of these two binomials is x squared. Okay, minus 4x minus 4x is minus 8x. Okay, plus 16. Okay, the next thing we probably ought to do is distribute that -2 into that parentheses. So all these guys have to get the -2. So -2x squared plus 16x minus 32 plus 35. Okay, and then we got a couple of like terms. Let's clean those up a little bit. So we get -2x squared plus 16x. Okay, and -32 plus 35 is just going to be plus 3. Okay, so what we did was we took something that was in intercept form, we put it into standard form, just really by multiplying it out all the way. Let's take a look at number 5. So again, I think the first thing we probably ought to do is multiply those two binomials together. So again, I'm going to go off to the side. I'm going to make a 2 by 2 box because I'm multiplying two things together. So x plus 7 times x minus 2. So the first top left box is going to be x times x, which is x squared. Okay, -2 times x is -2x. X times 7 is 7x. And 7 times -2 is -14. So my product is x squared plus 5x by combining those two middle terms, and then minus 14. So lastly, let's just go ahead and do our distributing. So we get -2x squared minus 10x plus 28. And what we did was we turned that intercept form into standard form.